Now, I'm not sure if this is going to be a mini lesson or not, but we're going to talk about a couple of rectangle examples. I'm going to try and go a little bit quick, but I picked one that involves a little bit of trig. That would be the second example. Now, again, we're looking at parallelograms, special parallelograms, which means we're going to take a look at the rectangle today. And each rectangle will have all the properties of the parallelogram, including diagonals bisect each other, but in addition, angles are 90 degrees, diagonals are congruent, and diagonals bisect each other. So we're going to practice a lot of these properties right here. So our first example is straightforward. So we have RPI is equal to 20, and I drew the big one down here. So let's go RPI. So this right here is 20. Now, given one angle of a rectangle, I can find all the other angles, every single one of them, because we're going to use all our definitions. One of them is this is equal to 90 degrees right here, so we know this is 70. And alternate interior angles, of course, this will be 20 and this will be 70. But more importantly, since we know that the diagonals bisect each other, and they are congruent, we have isosceles triangles all over the place. So we have a 20 here, we have a 70 here, and we have 20 here, and a 70 here, and this has to be 40, all right, and this has to be 140. That looks like that is a 4, and so on. So I can fill out everything. So if RPI is 20, then GIP is also 20. All right? If GI is 15.2, GI is 15.2, this whole thing right here. Let me erase all this. So we got 15.2. This whole thing is 15.2. Then RS, which these are congruent, is going to be half that. That's going to be 7.6. So 7.6. So this is 7.6. And I'm going to erase all this. Okay. PS is 6x minus 4. So PS is right here, 6x minus 4. And GI, which is this whole big thing right here, is 28. So this is all 28. Well, again, all these four segments right here are congruent to each other because they bisect and they are congruent. Because remember, on a parallelogram, when we straighten out the sides to make these 90, these travel the same distance. So we have basically 6x minus 4 is equal to 28. Half that. This is 14. So this is 14 right here. This is 14 and so on. So we got 6x minus 4 is equal to 14. 6x is equal to 18. And of course, x is equal to 3. So we put a 3 right here. Let me erase. And again, put all these on pause, and hopefully you are doing these on your own instead of just passively watching. So now our last one is RPI. RPI is 5t. This is a good example right here. I like this one. And PGI is 8t minus 1. So this is 8t minus 1. Okay? That is a 1. See it right here. Now, what I like about this one is we can use several different ways to approach this, but my favorite one is understanding that these are isosceles. So here's my base angles. So this is also 8t minus 1. And this whole thing right here is right. So this all adds up to 90 degrees. So watch, we have 8t minus 1. Hey, watch it. It's not, my pen is being very mean to me today. Of course, I had to use t's. So I got 13t plus 1 is equal to 90. So 13t plus 1. Did I put a plus? I can't even read my own writing. 1 minus 1 is equal to 90. 13t is equal to 91. And that's going to go in 7 times. T is equal to 7. All right? Boom. Now let's watch this next example. This one is going to be interesting. So we have ST is equal to 15, and all these apply to the same problem. So ST is 15. That means this is 15 and so on, okay? AST is 80. So here's my angle of 80. So I could fill in all the other stuff. Let's change it. Well, I'll just keep it. So this is 80. This is 100. This is 100. And knowing my definitions of isosceles and all that, if this is 100, these have to be 40 each because it has to add up to 180, right? So those are 40 each. This has added up to 90, so this is 50, and keeping with the isosceles. So we have a bunch of 40s and 50s here, okay? So we filled out all the angles. So the angles are easy. We got A at ATS. So here's ATS, that's going to be 50. And SMA, that's going to be 40. Here's the problem, and this is why I picked this one, is that we need to find AT. Well, let me erase all this again, and I'm just going to show you what we're looking at. We have a basic triangle where we have 50 and 50 here. ATS is 50 and 50, and of course this is 50 over here, and this is 40. And this whole thing right here is 30. So this is all 30 in length right here. And we don't have two other sides. So we can't use the Pythagorean. We're going to have to use trig. So that's exactly what we're going to set up. I'm going to bring down this right triangle. See what I did? I took this right triangle, brought it down so we can visually look at it a little bit better. And I have my 50, 40, 90 right triangle. So I have 50 here. I have 40 here, and I have my right triangle, and this side is 30. So I'm going to take a look at this, and I need to solve for this right here, x, call that x, and call this length y. So I'm going to look at my angle. I could do one of the others. It doesn't matter. I could do, let's take 40. I'm going to look at my angle. I have opposite and hypotenuse. That means sine. So I'm going to do sine of 40. Oh, my pen is not working. Sine of 40 is equal to opposite over hypotenuse. Multiply by 30 on both sides, I get 30 sine 40 is equal to something. Well, that something is going to have to be done on the calculator, so let's go over here and do that. So I have 30 sine 40, and I get about 19.28. So we know this is going to be about 19.28. Now we're going to solve for the y. Well, this is going to be adjacent over hypotenuse, so we're going to have cosine of 40. Cosine of 40 is equal to my adjacent over my hypotenuse. So that's going to be 30 cosine 40. Let's see what that turns out to be. 30 cosine 40. 30 cosine 40. Boom. And that's about 22.98. So I got about 22. My pen is evil today. 98. Okay. So this length's about 22.98 and this one is about 19.28. Now, when we, so let's go ahead and, so this is MA. So this is 22.98. So this one is 22.98. And this one right here, AT, is about 19.28. One quick interesting thing, watch this. So we would have A squared plus B squared equals C squared. Watch this. I'm going to do 19.28 squared plus 22. This is a good way to check your work. 8 squared. Okay? And that comes up, that is, okay. So 899.798. Yeah, I forgot, I'm rounding. So watch what 30 squared is. Boom, 900. All right, so that's pretty darn close. And what we did was we rounded here. And that is it for a basic trig problem. Study this problem. It doesn't mean it's going to be on the test, but this is a very, very good EOC-ish type problem. All right, till next time.